Hello everyone. Today we'll try to learn how to draw the CMOS inverter circuits layout. We all know that this is a CMOS inverter circuit where you'll be having a PMOS, then NMOS, and these two PMOS and NMOS are connected through the gate terminals, and the shorted gate will be applying the input signal, and to the shorted drain terminal here, this is a drain of PMOS and this is a drain of NMOS. The shorted drain we will be connecting the output. So here first, just looking at the CMOS inverter schematic, we are trying to draw the layout. So first we should draw the P diffusion for the designing the layout of PMOS. So the P diffusion will be like this. Try to draw the P diffusion. That is nothing else but you will be drawing a rectangular box which is acting as a P diffusion. The width of this one will be 4 lambda and the length is variable. And similarly, after drawing this one, we know that you can see here the PMOS has got the source terminal over here and drain terminal in the downward direction. So for that one, what I'll try to do is that I'll try to draw in this direction here 4 cross 4 with a layer called metal layer. I'll use a metal layer in the 4 cross 4 dimensions. This is the width of that one and length of the metal layer is 4 cross 4, and this acts as my metal layer, which will be nothing else but will be called as a source terminal. This is my source terminal, and then similarly over here I'll be drawing a 4 cross 4 width 4 and length 4 for the drain terminal, and this will be acting as a drain terminal. So what I do is that in order to make a patch up between the P diffusion, this is my P diffusion between a P diffusion and metal layer, I'll be putting this contact over here. This both are the contacts. So now I have completed the two terminals of the PMOS. Now the next terminal is gate terminal. So the gate terminal will be drawn with the help of polysilicon. The width will be of 2 lambda and the length is variable. So this is 2 lambda width for the polysilicon, which will be acting as an gate terminal. In the similar fashion, once if you complete the source, drain and gate terminal, upon this particular layout, you are supposed to draw 6 lambda, that is the width of 6 lambda and the length is variable, and this is nothing else but this layer which we have drawn just now. It is of 6 lambda width, which is nothing else but it is an N-well. So now we are trying to draw our CMOS inverter with the help of N-well technology. So there is an N-well technology CMOS inverter. Now once if you have completed all the source, drain and gate terminal of a PMOS, now we'll go for the drawing of NMOS. In the similar fashion, just below this one, exactly below the P diffusion, draw the N diffusion of just like a rectangular box, and after that one here you can see that the drain is in the upward direction and source is in the downward direction. Since I need to connect both the drains over here, I'm trying to draw the drain. I'm trying to take this part as a drain. Why? Because it is a flexible in the NMOS layout to take the drain either on the right side or left side of this particular rectangular box. So since my drain is over here, so the flexibility is there in order to consider my drain. So I'll be considering the drain of NMOS just below the drain of PMOS. Why? Because I need to make a shorting of these two drains. Now I have drawn this drain terminal 4 lambda, and this rectangular box which is used to draw the NMOS layout, it is called as an N diffusion. It is an N diffusion layer. Once if you complete that one, the source of the NMOS is in the downward direction, so I'll take it in the downward direction. I'll put the source terminal with the help of a metal layer. All the source terminal, gate terminal, source terminal and drain terminals have been drawn with the help of metal layers. So this is your source terminal. Once if you draw the drain terminals and source terminals on the N diffusion, now you are supposed to use the contacts to make the patching between the N diffusion and the metal layers. And you can see now here both the drains are connected, so short this both the drains. Since both this drain and drain are of same kind of material, no need of using any kind of contact over here. And after completing the source and drain of NMOS, now you can draw the gate terminal. The gate terminal of NMOS will be drawn with the help of same kind of material which is used to draw the gate of PMOS, that is polysilicon. We are drawing it with the help of polysilicon and the width is of 2 lambda. Same. Now you can see the input is connected at the shorted gate terminal, so you can short this one. One thing you are supposed to keep in your mind, whenever you short the same kind of material, the contact is not required. So once now we have completed the part of the layout, now we are supposed to make the input and output connection. So see now, output is given at the drain, shorted drain terminal, so I'll use another kind of metal layer or the similar kind of metal layer, and this will act as my output terminal, and input is connected to the polysilicon, so I'm using a kind of metal layer. Since I have used a metal layer upon the polysilicon, I'll be using one kind of contact over here wherever this crossing of metal takes place upon the poly. So now this will act as my input terminal. Now we have completed the layout of a PMOS and NMOS. The next important point is you are supposed to give the VDD and ground terminal. The ground is connected to the source of NMOS, so here you make a ground terminal with the help of cross mark, and this will act as a GND ground, and here the VDD should be connected to the source of PMOS. So here the VDD is connected with the help of this contact, that is VDD, and this is a complete layout of your CMOS inverter. But one main thing is that in order to make sure that in order to make you know about this N well, I am trying to draw this resembling this N well with the help of this cross lines. This cross lines indicates an N well layer. When you go to simulate of the simulation part of this CMOS inverter, the simulation will not take place because it tells that the well is floating. So in order to avoid that floating, you are supposed to put one VDD source to the N well, then the floating problem will not occur and the error will not occur, and you can go for simulation of this CMOS inverter. So this is regarding how a CMOS inverter layout can be drawn very easily with the help of N well technology. Thank you everyone.